All right, folks, I want you to set up your notes just like this. You got the midpoint formula and the distance formula. These are the two main concepts that we're going to be talking about today. But there are some basics that, maybe some of us have forgotten. So let's talk about if you had a point, right? And that point was some X amount over, some Y amount up. We'd call it XY, the point XY. Now, if that point was not in the first quadrant, so I'm going to take this point right here, I'm going to move it. This is the first quadrant, right? It could be over here in the second quadrant. That would mean the X value is negative, right? We're coming back on the X axis and then we're coming up some Y amount. So the X is negative, the Y is positive. This is the second quadrant. And then down here's the third quadrant, and this is the fourth quadrant. So that's just a little review, right? If the point is sitting on the axis, it's not in any quadrant. That's none, right? So let's list that right now. So I might just put a Q1 right here for quadrant 1. This is quadrant 2. This is quadrant 3 down here, and quadrant 4 over here. Now, today we got two pretty straightforward formulas that we're going to have, and we're going to put them over here in our notes once we develop them a little bit, okay? So let's give our point over here some numbers. Let's say we came over 5 and we went up 4. Okay, so I'm going to put over here 5 comma 4. And then we're going to put another one over here. I don't know. Let's go back, say we go back 2 and up 1. So that would mean I'm in second quadrant and I'm going to go -2, 1, right? This is my X value. This is my Y value. If I want the midpoint between these two, let's connect them right now, okay? So I'm looking for this point that's right in the middle. And the book does kind of a cool thing. It does this little drawing. It says, we would have to come over a certain amount, we'd come up a certain amount. We'd go over a certain amount, and we'd come up a certain amount. And what they try to do is they prove that these two triangles are congruent. And if this is the middle, then this piece right here is equal to this piece over here, and this angle would be equal to this angle because they're corresponding angles, and this angle here is congruent to this one because they're corresponding angles, and the two triangles are congruent. So by angle side angle, they're congruent, and they go through this whole proof, which is pretty darn cool of why the midpoint formula works. But I want to break it down a little bit more simple than the proof. Okay, so let's say you met a friend, and this friend has an older brother, and so you're kind of like, hey, how much older is that person? So let's put over here friend's brother. Okay, this is my story I have for you. So let's say you're 16 years old, and I'm going to come over here. I'm going to put down you are 16. Once my pen starts writing, and your friend's older brother, let's make this real easy, is 20. Okay. And you're wondering what the distance between those two numbers is. Okay, so how far apart are those two numbers? Well, you can see it's 4, right? I mean, I don't need fancy arithmetic for that, but the arithmetic that would be needed if it was more complicated would be you take 20 minus 16, 20 minus 16, putting the answer down there, right there, and that would give you 4 years. That's the distance between your two ages, right? Now, let's say you wanted the average of your two ages. I think probably you can see the average is 18, halfway in between those two. So you could take the distance, cut it in half, and then add that to 16, right? That would get you to the 18 number. But there's a little way, a method that we can do to get the average. You add the two numbers together. So I go 16 plus 20, and you divide that by 2, right? So that's 36 divided by 2. That gives you 18. So when we're looking for the average, you add and divide, right, by the number of items that you have in the numerator. You divide by that number, and that gives you the average. If you're looking for the distance, you subtract. So we're going to use that property back here when we're talking about how would I find the midpoint right here. Well, the midpoint is the average of the x's, and it's the average of the y values. So what I'm going to do right here to find my special midpoint is I'm going to add the x's together. So let's put down -2 plus 5. So -2 plus 5, and I'm going to divide it by 2. And then I'm going to add the y's together, 1 plus 4. So 1 plus 4, and I'm going to divide that by 2. And this is going to tell me what the midpoint is. So let's check it out here. So I get 3 divided by 2 is 1.5. So 1.5. And then 1, let's see, that's 5 divided by 2, that's 2.5. So it's 1.5, 2.5. So that would mean if I accurately drew this, I'd come over 1.5 and I'd go up 2.5. Sometimes I don't like putting tick marks down because it might not look very good. So I'm going to label my point. As soon as I label it, then there's no doubt about it. This point is at 1.5, comma, 2.5. That's how we find the midpoint between 2 points. So if I had like, I don't know if you want to do this or not, but you can put x sub 1, y sub 1. This was my first point over here, right? And this was my second point over here, x sub 2, y sub 2. And what we did was we added the x's together. So x sub 2 plus x sub 1, and we divide that by 2. And we do the same with the y. So y sub 2 plus y sub 1, all divided by 2. That's our midpoint formula. Add, divide by 2 is going to tell you where the middle is. Okay, so how about the distance formula? How do we use the distance formula now? What's the distance between those 2 points? Well, here, let's think about for a second, instead of these 2 littler triangles, let's make one triangle to go from one point to the other point, okay? So I would have a right triangle right here because I'm going straight horizontal and then I'm going straight up vertically to get to this point over here, 5, 4, right? So how far, what's the distance that I need to go along the x direction? Well, back on this page over here, didn't we subtract the 2 numbers? We subtracted 6. We took 16 away from 20. That gave us 4 to figure out what the distance between those 2 numbers is. Well, that's what I'm going to do over here, but I'm going to subtract the x's. So I'm going to go 5 minus negative 2. I'd like to take the bigger number minus the smaller number, but it really honestly doesn't matter if you mess up the direction because I'll show you here in just a second. So I'm going to go 5 minus a negative 2, and that distance is 7, right? So it would be like 2 to the y-axis and then 5 more to get right below this point. So that kind of makes sense, right? 2 here and 5 over there gives us a total of 7. So, the arithmetic, though, the formula is going to go 5 minus the negative 2. Okay, so 7 is that distance. What's my distance coming straight up this way? Well, I would need to subtract the y value. So I'm going to go 4 minus 1. So let's do that right here, 4 minus 1. Okay, so that distance is 3. All right, so we've got a distance of 3 there. Now, the Pythagorean theorem can be used to find out how long this side is. Quite often we call the hypotenuse C, and we call the legs A and B, right? So I got A here, and I got B here. And so what I'm going to do down here for this calculation is I'm going to go C squared is equal to A squared plus B squared. And my C squared is equal to 7 squared plus 3 squared, right? And then I got to take a little further here. I'm going to go C squared is equal to 49 plus 9, right? So 49 plus 9 gives me 58. So now we have C squared equals 58. And then we are going to take the square root of both sides, right? So square root of 58. Now, when I use numbers, sometimes I lose track of what my formula is. So let's go back and study our formula if you called this point over here x sub 2, y sub 2, and this one over here x sub 1, y sub 1. So how did I get that 7 number right there? Where'd that 7 number come from? Well, it was, how did I do that? 5 minus a negative 2. Where'd that 5 come from? It was this one right here, x sub 1 minus my x sub 2. So I did x sub 1 minus x sub 2. And then we're going to square that, right? So we're going to square that. And then we add, and these were the y, this 3 came from the y's subtracted from each other, right? The 4 minus the 1. So I'm going to go y sub 1 minus y sub 2, and I'm going to square that. And that's all equal to c squared, right? So this was all equal to my distance. C is like my distance between the 2 points, right? My distance. And so let's see, what did I do then? I took the square root of both sides down here, right? So right here, I think that's what I'm going to do. I'm going to take the square root of all this stuff. So I get x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared, right? And we're taking the square root of all that stuff. So that's the formula right there for the distance. Okay, so let's come back over into our notes and let's copy that guy right there. Okay, let's see if I can do that real quick here. Take this and I'm going to copy it. Let's see, which one's my copy again? I think it's this guy right here. And then I should be able to drag it. Let's keep our fingers crossed. Oh boy, it's not letting me drag the whole thing. Maybe it wants me to paste it over here. Let's see if I can paste it. There we go. Okay, so my distance formula, boom, I got it right there. We're going to do problems where it says, hey, find the distance between these 3 sides and show that these 3 sides would make 3 sides for a right triangle. So that's one of the first problems we're going to do in class together, and we're going to talk a little bit about like how would you know it's a right triangle, but we're going to practice the distance formula. It's problem number 19, I think. Let me check. It is actually problem number 31 is the first one that we're going to do in class, because it involves 3 different distance formula calculations and then proving that you have a right triangle. If you're going to show that you have a right triangle, you're going to use Pythagorean theorem and show that a squared plus b squared equals c squared. So 31, that's what you want to do. You want to find the 3 lengths of the sides and then use the Pythagorean theorem. I hope this helps you to complete the homework tonight. Thanks for tuning in and taking some notes. All right, good luck.